Welcome back, everyone. This is a continuation of the architecture series, and part 2. We're going to go back and discuss some components that we didn't talk about in the first video. In the first video, we talked about search heads and search head clusters, but we did not discuss how a user actually accesses those search heads. If there's 3 search heads, which search head does the user use? This is where we need to discuss load balancing. The common way to load balance user requests is to provide a DNS that round robins to all of the search heads. Another component we haven't discussed is licensing. In Splunk, you are charged for how much data you ingest daily. This is measured in gigabytes. To manage license, we have another server. This is called the license master. The search head tier, the indexer tier, the configuration tier, and some of the forwarding tier needs to communicate with the license master to continue functioning correctly. A common design decision to save on resources is to combine the license master functionality onto the deployment server. In the first video, we discussed using a forwarder to ingest data on endpoints. But what happens if the system we want to ingest data from can't install a forwarder? Now we need to introduce a whole new concept called syslog. Essentially, if we look at our previous example log file, some systems, instead of writing their logs locally, can send them remotely. We send these to a system called a Syslog Collector. If the Syslog Collector is a Linux system, it will have rsyslog or syslog-ng. If it is on a Windows system, it will have Kiwi. Regardless, they work exactly the same. They both listen on a port, listening for syslog messages, and then writing locally to disk. Just like we do with other endpoints, we then install a forwarder on the Syslog Collector to monitor the log files that were collected and written locally to disk. But what if our data isn't in the form of a log file? What if it's inside of a database or an application? At that point, we need another server called a heavy forwarder. Confusingly, heavy forwarders are no different than full instances of Splunk. We use heavy forwarders when we need to offload ingestion tasks that are based on scripts. Specifically, when we're pulling data from a database, we use an app called DB Connect. When we want to pull data from an application via API, there is usually a third-party vendor app on splunkbase.com. If you need to save on resources, you can install the DB Connect and vendor apps on the search head or configuration management tier. However, best practice is to always put it on a heavy forwarder. The last thing I want to talk about is the ports that these systems use to talk to each other on. Unfortunately, they're not really standardized. We'll go over some of the ones that are pretty standard. When a user tries to access the web UI, they either go through port 80 for non-SSL or 443 to SSL to the load balancer, at which point it redistributes the request over to the search heads on port 8000. Any Splunk to Splunk communication, such as configuration management or search, happens over port 8089. Any data sent to the indexers from the forwarders is sent over 9997. Any UDP syslog is generally sent over 514, with TCPs being sent over 515. These could be moved to 5514 or 5515 respectively. Now for the ports no one seems to agree on, for index replication we do 8080. For search head replication we do 8181. There is additionally the KV store replication port, which is 8191, as well as a HEC token port, which is 9887. These will be talked about in later videos.